Okay, guys, here we go. We are again, topic 4, rate of change. We're on student activity sheet 4, exploring rates that are not constant. So just a quick recap here, guys. When we talked about constant rates, constant, maybe you might want to write this down on your paper, okay? Write it anywhere here. Constant meant that it either as one increased, the other increased at the same rate. Okay. When we talk about non-constant, while one goes up, the other may go up, but it may look slightly different. It may have more of a curve to it as opposed to a straight line. Okay. All right. So let's go ahead and talk about this. Nope, I'm on the wrong thing here. Give me a second. I apologize on this, guys. Chose the wrong non-constant thing. So with this, we talked about our skateboarder and Terrence the skateboarder, and we moved him back and forth. So we started him at 0, and we said this is what happens if we graph, and we're kind of moving at the same whoa, and we move him all around. And we look here, he's holding still, up, down, woo, okay? So what we want to talk about, there's parts of this graph. If you look, there's parts, I see straight lines, that is constant movement, a straight line, constant movement. But I get these curves here. And because this graph is not steady from one side all the way to the next, this is what we call non-constant. Okay, so I want to take a look at this first section here. We have this graph here. I want you to look at this curve. Let's think about how we're going to get Terrence to go over there. So I'm going to do a couple of things. So Terrence is starting over here at 0, so we got him right next to the motion detector. If I just go whoop, that's not getting me there. Okay, so let me reset it and bring Terrence back. I know as I'm looking as time goes on, his distance is not increasing very much. So I'm going to go nice and slow with that. Maybe he gets a little further, and I see we're starting to go up. So I'm going to move my dude a little bit faster. And then he shoots up. So you see, I can vary a little bit here, but it's a nice gradual. He starts off really slow and then moves faster till he's further away. Okay, so how did I move Terrence? I think his name's Terrence. We're just going to call him Terrence. By moving away very slowly from the detector, then I gradually picked up pace to get the furthest point away by the end of the time. Okay, what I want to talk about here, or note, it's not a constant speed. Okay, the speed at the beginning does not equal the speed at the end. Okay, the speed at the beginning does not necessarily equal the same speed in the middle or at the end. So now let's take a look at question number 2. So on this one, it's the same idea. It's not going to be a straight line, okay, but this time it's going to be a curve, but it's totally upside down. How in the world am I going to make this graph? So again, if I play around with it, I'm going to bring them back here. I know if I do my steady line, that gets Terrence away. Well, I know if I'm up here to get him back, I'm going to have to bring him back. Now, I'm going to have to work on my graphing ability here. But you see, I got to move him all the way away. By 5 seconds, he is all the way back. So let's try this again. So I'm going to go faster. Oh my goodness, I am really off here. And we're going to hang out here for a little bit, and then, whoa, apparently I'm not good at this. Okay, so you guys can judge me on my graph. If you think you can do better, get on Agile Mind and do it yourself. Okay, so what actually happened in this graph? Let's ignore my crazy jumping all around here, and let's talk about what actually happened. Okay, so from Terrence to here at point 0, 0 feet, 0 seconds. Okay, Then he quickly sped up and then slowed down as he got further away. He kind of hung out around the 8 foot mark for a little bit. And then he slowly started moving back towards the detector until he got really close, in which he sped back. Okay. So I had him move quickly all the way away, slow his speed, and then quickly come back. Okay. He has to go away from the detector to get all the way out here in order to come back. Okay, let's go on. Okay, so let's just pay attention. Let's look at this graph here and see if we can figure some stuff out. So I want to try to match each section of this graph to some words here. They want to know which segment is horizontal. If you guys remember correctly, horizontal is a straight line from side to side. It's like looking at the horizon of the sun. So when I look at what's moving side to side, that's point B. Okay, so I'm going to drag B there. What do you think's happening at point B? Well, when I look at this, I see time is moving on, but I'm not getting any further away or any closer. Okay, when we have a horizontal line, guys, that means that the skateboarder is still. He's not moving. Okay. Now they want us to look at, it says the skateboarder is moving blank during segment A, then segment C. So let's compare segment A right here to segment C. Well, here, when I look at the change, I see one is going away, one is coming to. That's not really an option. Okay, I have faster and slower though. So when I look at A, it's going, we'll call it like 1 second. It's going really far away. And in C, we'll call it like 2 seconds it's taking, and it's not going nearly as far as A did. A is covering more distance in a shorter amount of time. A is going faster. Now it says segments D, E, and F all show a blank rate. Well, we know we're comparing three things, okay, that have to be the same because they're all showing it. While D looks totally different. So I'm going to call this A, B, and C are all showing what kind of rate. This one, for each foot that we go on, we're moving the same amount of time here. So we're going to call it constant. While A, B, and C are not the same rate within themselves, they are each constant. Then the speed of the skateboarder at the beginning of segment D is blank than the speed at the end. So at the beginning of segment D, it's real low and shallow. Okay, time goes on, but distance doesn't increase very much. Then all of a sudden at the end, the distance shoots up in a really short amount of time. Okay, the speed of the skateboarder at the beginning of D is slower than at the end of D. Slower at the end of D. Okay, so you should have those answers down. Moving on. Okay, question 4 here. Okay, when I look at question 4, we have this graph of Terrence the skateboarder. See, his name is Terrence. Okay, what they want us to do is take note of the his time compared to his distance. So at 0 seconds, he is 2 feet. At 1 second, he is at 3 feet. At 3 seconds, he is at 7 feet. At 5 seconds, he is at 9 feet. At 8 seconds, he is at 8 feet. And lastly, over here at 10 seconds, he is up at 7 feet. Okay, now what they want us to do, okay, and that was, I completed the table there. Same thing that they have down. Okay, now they want us to find the change between the first 2 points. So from 0 to 1, it goes up by 1. And from 2 to 3, it goes up by 1. Yay! Okay, now they want us to use these values to find the average rate of change. Now, one thing I want us to note when we talk about average rate of change. I'm going to average rate of change. What does that really mean? That means our change in distance divided by our change in time. Okay, so between that time, he goes 1 foot in 1 second. Well, 1 divided by 1 is just 1, meaning he travels at 1 foot per second during that time. And that's exactly what I have here down here on B. So let's flip our page and head to question C here. Okay, so now for question C, they want to know the rate from 1 to 3 seconds. Okay, so from 1 to 3 seconds, when I look, I'm increasing 2 seconds and my distance is increasing by 4. Okay, so we're increasing from 4 feet in 2 seconds. And then we reduce that. 4 divided by 2 is 2. He is traveling at 2 feet per second. Okay. And then lastly here, they want us to calculate the other 3. So from 3 to 5, it increases by 2. From 7 to 9, there's an increase of 2. From 5 to 8, there's an increase of 3. Be careful here. From 9 to 8, that is going down 1. So we have to throw that negative in there. And then from 8 to 10, there's an increase of 2. Again, be careful. From 8 to 7, that's going down 1. Okay. So with this, guys, I've gone and I have shown the different changes here, the same thing that's on the table. Now they want us to find what his average speed is during each of these intervals. Okay. So what we're going to do is we're going to sit and calculate this out. We said 2 over 2 from 3 to 5. 2 feet for 2 seconds. That simplifies into 1 foot per second. On this next one, again, the Y goes first. From 9 to 8 and 5 to 8. He is going down 1 foot in 3 seconds. So his speed, negative 1/3 of a foot per second. And from 8 to 10 seconds, I apologize for my scribble here, guys. He is going down 1 foot in 2 seconds. Well, all that simplifies is to down 1/2 foot per second. Okay. Now that we have gone through and we have found all the different changes for each interval, let's just think about what we've seen. Okay. When was Terrence going the fastest? Well, we've got 1/2 foot, 1/3 of a foot, 1 foot, 2 foot. He also had 1 foot right here. Okay, so for all that, his fastest time was from 1 to 3 seconds. From 1 to 3 seconds, he was moving at 2 feet per second. Okay, what about his slowest time? I don't want you guys to get caught up in the negatives. Remember, we can't move at a negative speed. Okay, all these negatives mean right here was that he was moving backwards. Okay, don't go thinking like Back to the Future and things like that. No, he was just going backwards. Okay, we cannot go negative speed. We can only have a positive speed, but his distance from the camera was decreasing by 1/3 of a foot. His slowest time was from 5 to 8 seconds right here, where he was going negative 1/3 feet per second, which is really just traveling at 1/3. Again, all the negative means was that he was moving backwards. And then from 0 to 1 foot and from 3 to 5 feet, he was traveling at the same speed of 1 foot per second. From 5 to 10 seconds, he was moving negative, again, which means that he was simply moving backwards. He wasn't going at a negative speed. Okay, let's go on. Okay, so now I've got another graph here for us to look at. Okay, What I want to do, we're going to graph each of the points on, well, not graph, we're going to make a table for each of these points. Okay. So what I did here, guys, is I said, we've got the point 1, 6, we've got the point 3, 4, 5, 2, 7, 3, and 9, 6 up here. Okay. So all I did was I recorded those in the table. Then they want us to find the rates. Okay. So I did the same thing that we did on the other side. I said from 1 to 3 seconds, it was +2. From 6 to 3, be careful. This is a -3. From 6 down to 3. From 3 to 5, it's 2. And from 3 to 2, it was -1. Again, it went down. 5 to 7 is 2. From 2 to 3, it's a +1. And 7 to 9 is 2. And from 3 to 6, it's +3. Okay. So with that, let's find each of what the average rate of change is between each of those intervals. So on this first one, we say it's -3, because I found the difference of 3, over 2, which is -3 over 2, or we can call it -1.5 feet per second. He is moving closer to the detector at a speed of 1.5 feet per second. From 3 to 5 seconds, he moved 1 foot closer for every 2 seconds. So that translated to a half foot closer. Again, that's negative. He moved a half foot closer per second. From 5 to 7 seconds, we changed direction here. Instead of getting close to the camera, he started getting further away again. And he was going at a rate of 1 over 2, 1/2 foot. So a half foot per second. And lastly, between 7 and 9, he picked up some speed here and went 3 over 2, or 1.5 feet per second. Okay. Then they're going to ask us to do something a little different here. Okay. They want us to, let's talk about when was he moving the fastest. So let me pull up the table they got here. Okay. Here's our rates of change. What is the fastest movement? Okay. He was moving the fastest in 2 spots. He was moving the fastest from 1 to 3 seconds and from 7 to 9 seconds. That's 1.5 feet per second. He is moving there. Okay. 1.5 feet per second. Even though one of them's positive and one of them's negative, again, guys, they're moving at the same speed. It's just different directions. This one's getting close to the camera. This one's moving away. Our slowest was from 3 to 5 seconds, and then again from 5 to 7 seconds, where they're moving at half a foot per second. So again, one's negative, one's positive. All that means is that from 3 to 5 seconds, he was getting closer to the camera, and from 5 to 7 seconds, he was moving away from the camera. Okay, the next question they want to ask us, what is the rate of change from 3 to 7 seconds? Okay, so what this means is I'm going to come over to my table and I'm going to write down the points again. I am going to not worry about this 5 to 2. So from 3 to 7, that was a difference of 4 seconds. From 3 to 3, that's a difference of 0 feet. Okay. 0 feet in the course of 4 seconds means that he averaged 0 feet per second. Okay. Now, did he move? Yes, he moved. But what was his total distance changed between that time? 0 feet. Okay. While he moves both backwards and forwards, his total distance is where he started to where he traveled to, which was 0 feet. Okay. On to question 6. Let's go to question 6 here. Okay. Again, we got this graph. Okay. We talked about previously that when it's not going up or down, that means they're standing still. We're going negative, positive, and a positive, negative. We're talking about constant rates and non-constant rates. Okay. So it says segment A. So I'm looking up here at A. Indicates a rate of change equal to what? Well, I'm neither increasing or decreasing my distance, which means it's 0. Section B indicates a rate of change that is blank and constant. Well, they already said it's constant and it's going down, so we're going to call that negative. Section C indicates a rate of change that is blank and blank. Well, going off of what's here, I'm going to look here. Again, I see it's constant, and instead of negative, it's going up, so we're going to call that positive. Constant and positive. Section D. Ooh, this time it's not a straight line. We got a little bit of a curve going on. When we got a curve, guys, that means that it is not constant, but they also tell us it is positive. So section D is positive and non-constant. Section E, if you guys look at section E, again, guys, section E is curved, which means it's non-constant. And this time it's going down, which means it's negative. And then lastly, according to the graph, Terrence was moving blank during the time represented by section B than during section C. So from section B to section C, I know B is negative, C is positive. Well, that doesn't really matter because we talked that there cannot be a negative speed. But B, I'm covering 1, 2, 3 feet in 1 second. Whereas in section C, I'm covering 1 foot in 1, 2, 3, 4 seconds. I am moving a heck of a lot faster in B than I am in C. Okay? And that, ladies and gentlemen, is the end of student activity sheet 4. Your teacher will go over things with you and work with you on the reinforced questions.